In this video, we're going to cover periodic functions, graphs of sine and cosine, and the angular and linear velocity questions. So let's start here with questions 19 and 20 on periodic functions. We've got a periodic function graphed here, and the first question just asks us, what is the period of this function? Now the period is how long it takes to complete a full cycle of the function. How long can we go before the function starts repeating itself? So if I start here at 0, I can see that the function goes up, back down, up, here, and now I'm back at 0. And then notice it starts repeating itself again. And so this right here that I've highlighted in green, that's one cycle of the function. And the period is this distance right here, which is 4. So the period of this function is 4 units. So we're going to use that idea to find future or past values of the function. First question here says, what is f of 12? Now if I think about 12, what I want to do first is find a number close to 12 that is divisible by 4. Well, 12 itself is divisible by 4, and so that means that when I reach 12, I'm actually going to be right here at the beginning of the cycle. And the function value at that point is 0. Now, f of 15, that's going to be 3 units after 12. So at 12, if I'm at the beginning of the cycle, then f of 15 right here would be 13, 14, 15. And that corresponds to this point in the cycle. And that function value is 1. All right, next one, f of 38. So I want to find a number close to 38 that's divisible by 4. And so I'm thinking 36. Whenever I'm at an x value of 36, I would be at the beginning of the cycle. 38 is going to be 2 units later, so 37, 38 would be right here, and that corresponds to this point in the cycle, which is at -2. Now negative 21, I've got a negative x value for this question. And we're still going to work this the same way, except we're just going in the negative direction. So a number close to negative 21 that's divisible by 4 is negative 20. So at negative 20, again, I'm going to be at that starting point of the function, but then negative 21 is going to be 1 unit to the left from that point in the cycle, which corresponds to this point right here in the cycle, and that would be positive 1. All right, let's go to the next question. On the next question, we're asked to sketch a graph of y equals -3 cosine of 2x. So I've got a cosine function here with 2 transformations. First of all, well, actually 3 transformations if we count that negative in the front as a separate transformation. But I've got the 3, and that means that it's going to change the amplitude of my graph. Amplitude is going to be equal to 3. And then I have a 2 here, which means my period is going to be changed. Period is going to be equal to 2 pi divided by b. That's our little formula. So in this case, 2 pi divided by 2 or pi. That would be the period for the function. All right, so we're ready to graph. Now I don't have a vertical shift or a horizontal shift, so my midline is going to start right here at 0, 0, at the normal place. The x-axis is going to be the middle of my graph. My amplitude is 3, and so I know from the midline I need to go up 3 and also down 3. And then the period of the function is 1 pi. And so I'm going to label I'm going to let each of those be pi over 4, just so the graph is big enough for you to see on the video. And so that means that pi would be right there. All right, so I've drawn my window pane here where we're going to graph our function. The width of that window pane is pi because that's my period. Period equals pi, and that's how long my window pane is. All right, so now we're ready to draw the graph. Actually, let me draw the midline here. Okay, there's our window pane. Now we're ready to draw the graph. It is a cosine graph, and cosine normally starts at the top of our window pane, but remember that this one is negative. And so instead of starting at the top, I'm going to start down here at the bottom. It's going to reach the maximum in the middle, back to the bottom by the end of the window pane. Zeros are right here in the middle. And so there is your cosine function. And then let me see if I can squeeze in one more cycle here. There we go. All right, next question. Now on this one, it looks like we've got all 4 transformations here. We have an A, a B, a C, and a D. So let's think about what each of these is going to do to our graph. That 4 in the front, the A, that's giving me my amplitude. So I'm going to have an amplitude of 4. I have a B value of 1/2. So my period is going to be 2 pi divided by B, which is 2 pi divided by 1/2, or 4 pi. So that B equal to 1/2 is going to stretch out our graph, stretch out the period to 4 pi. I have a C value of pi over 2, so that means I'm moving right pi over 2, and then a D value of 3. So we need to go up 3. So now I have all the information that I need. I'm ready to sketch a graph of this function. Here we go. So I like to always start with the horizontal and vertical shift, the right pi over 2 and up 3. And I need to label my x-axis. I'm going to let that be pi over 2, pi, so this would be 2 pi, 3 pi, and 4 pi. And let's see, right pi over 2 and up 3. So that's going to be right here. So that means that the midline of my window pane is going to start right here at this point. I went right pi over 2 and up 3. That's the beginning of the midline of my window pane. From here, I'm going to count amplitude. My amplitude is 4. So this is going to go up to 7 and down to -1. So I've gone up 4 units, and I'm going to go down 4 units. All right. And then the last thing we need to do is the period of 4 pi. Now I've got 4 pi marked right here, but notice my window pane is not starting at 0. It's starting 2 squares past 0, or at pi over 2. And so that means to get to 4 pi, if we want the width of our window to be 4 pi, then it's going to end 2 squares after 4 pi. So here's my period equal to 4 pi. The width of that window pane is 4 pi. So let's finish it off here. And the middle, that's going to be right here. So now we're ready to draw, get our graph inside that window pane. This is a sine graph. Sine normally starts in the middle of the window pane. So I'm going to start right here. It's going to max out in the middle of that section, come back to 0, hit the relative minimum in the middle of the next section, and back to 0. And there's our graph. And I don't think I have enough space here to do another cycle. I'll do half a cycle and fit it in. All right. This next question, we're given a graph, a little multiple choice question here. We've got these 4 equations, and we want to know which one of them is not an equation that represents that particular graph. So as I look at my answer choices there, they all have the same amplitude of 3. We've got the same vertical shift of 2. They all have a B value of 2, the period. It looks like the only difference here are these, the horizontal shifts. The first one doesn't have a horizontal shift at all. The next one minus pi over 2, so we have a shift of pi over 2. And then these two shift of pi over 4. So since that's the only thing that's different in each equation, I think that's the thing that we need to be looking at. So let's start here with our first equation, 3 cosine 2x plus 2. So I have no horizontal shift there, which means that my C value is 0 and the D value is 2. And so if I were sketching this graph, the midline of my graph would start at 0, 2. So I'm going to look at that point, which would be right here, 0, 2. And amplitude is 3. So that would go up to 3 and down, down 3, go up to 5 is what I should have said. Sorry about that. So it looks like if my x-coordinate is 0, that corresponds to this point on the graph, which is at a maximum, and so that means that should be a cosine graph. A cosine graph would be starting there, and this answer choice says cosine. And so that actually is an equation for this graph, and so it's not our answer, because we're looking for one that's not an equation that represents this graph. All right, so let's look at the next one. This one has a horizontal shift of pi over 2 and to the right. So if I go pi over 2 to the right, that means that the cycle would be starting here. And that's at a minimum on this graph, which means that that would be a negative cosine. And right here I have negative cosine. So that equation also works for this graph. If we have a horizontal shift to the right of pi over 2, then I do have negative cosine here. Let's try the next one, a shift right pi over 4. So if I go to pi over 4 right here, that corresponds to this point on the graph. And that point is in the middle. That's on the midline of the graph there at 2. And the function is going down from that point. So I'm starting in the middle, which means it's a sine function. But if I go down, then it should be negative sine. Well, if I look back at answer choice C, it is sine, but there's no negative in front. If I look at answer choice D, it's the same horizontal shift. So this point's also for D. And it is sine, and there is the negative there. So D is the correct one, which leaves C as the equation that does not work for our graph, and that's our answer. All right, here we have a real-world problem that can be modeled by a periodic function. The London Eye is the tallest Ferris wheel in Europe. Passengers enter the wheel at the bottom from a platform that's 15 meters above the ground. The wheel is 120 meters in diameter. It takes 30 minutes to make a full revolution. And the first thing that you're being asked to do here is to sketch a graph that models the height of the passenger on the Ferris wheel and write two equations, a sine equation and a cosine equation for that graph. So, we're just doing a sketch here. No graph paper. It doesn't have to be perfect. They told us that the passengers get on at a platform that is 15 meters above the ground, and the diameter of the Ferris wheel is 120 meters. So if the bottom of the Ferris wheel is 15 and the diameter is 120, then that means that the highest point that you're going to go is 135 meters, because then the distance between the platform and the top of the Ferris wheel would be 120. So my lowest point is we're getting on at 15. The highest point is going to be there at 135. Now we need to figure out where the midline is. If the diameter is if the diameter is 120, then half of that would be 60. So that's going to give me my middle line. If I add 60 to 15, that would be 75. And so at 75, that's going to be the midline of our graph. So we're going to start at 15. It's going to go through the middle, reach a maximum, come back down through the middle, and then bottom out down here. Now we need to label the x-axis. They told us that the ride takes 30 minutes. It takes 30 minutes to go all the way around. And so that means that we're going to finish that ride in 30 minutes. That means that the maximum is going to occur halfway into that ride at 15 minutes. And then our zeros, not our zeros, but the points where we're in the middle of the Ferris wheel at 75 meters, that's going to be half the time between 0 and 15, 7.5, and then this one would be 22.5. And so there's our graph that models a ride on the Ferris wheel. So now we need to write two equations for this graph. First off, I'm going to write the easiest equation to write would be a cosine equation. And in fact, it would be easiest to write a negative cosine equation, because if I start here at this point, I'm starting at the lowest point in that periodic cycle, which would indicate a negative cosine function. My amplitude here, remember that the amplitude is the distance from the midline to the top, from the midline to the bottom, and that's 60. We need to figure out our b value. To find b, I'm going to use 2 pi divided by the period, and in this case, that's 2 pi divided by 30. Which is reduces to pi over 15. Now the c value, that's what's going to change depending on which equation we're writing. Our c's are going to be different. But the d, that's always your midline, and in this case that's going to be 75. So again, I'm going to start with that negative cosine equation. So y equals negative 60 cosine, my b value goes right here, pi over 15, and then I have x. Now this negative cosine graph, remember it's starting right here, and my horizontal shift is 0, because I'm corresponding to 0 on the x-axis, so I'm going to put minus 0. You don't have to put the 0 in there. And then finally the d plus 75. So that's one equation. Now if I do a sine equation, everything's going to be the same except for that c value. So 60 sine pi over 15 times x, don't know what the c is going to be yet, plus 75. And let's go find a c value. A sine function starts in the middle, and if we do a positive sine function, then we're starting in the middle and going up. So that's this point right here. It's on the midline, we're going up, and that corresponds to 7.5. So that means that my C value would be minus 7.5. So those are two examples of equations that you could write for this graph. I'll give you two more. If we decided to do a positive cosine function, cosine starts at the top of the cycle, which would correspond to this point right here. And that x coordinate, that horizontal shift, would be 15. So again, everything else is going to be the same. Sine, cosine, pi over 15, x, and then plus 75. But that's going to be a horizontal shift of 15. And finally, we could write a negative sine function, which starts in the middle, and the graph goes down. And that would be, because I'll write down here, y equals 60 sine pi over 15 times x plus 75, and that point corresponds to 22.5 as a horizontal shift. So any two of those functions would be acceptable answers for this question. All right, so now we have a couple questions to answer about this graph. Whoops, sorry about that. First question is, how long does it take for the passenger to reach a height of 100 meters? So to answer this question accurately, what we want you to do is to use your calculator. And you can go to the graph page on your calculator. And I can't really give a calculator screenshot here, so I'm just going to, let me just sketch the graph again. So here's our graph. And what we want to do is graph this by entering in one of the equations that we wrote on the previous question. Enter one of those equations in, you should get this graph. And then in the next function, you're going to graph f2 equals 100. And so I'm going to say on my picture 100 is about right here. So if you do that, your calculator screen, you should have a graph that looks something like this. You've got the F1 graph, which is our cosine, or our periodic graph, sine or cosine, depending on which one you put in. And then our second function that's equal to 100. Now, how long it takes for the passenger to reach the height of 100, that's this point right here. We want to find the intersection point. So on your calculator, you're going to go to Menu, Analyze Graph, find the intersection. And if you do that, you're going to get the point 9.552, 100. That's the intersection point. And so this number here, that's the time. That's how long it takes to get 100 meters off the ground, 9.552 minutes. The next question, what is the height of a passenger 25 minutes into the ride? So this time, the information that's given to us, the 25 minutes, that's a time or an x value on our graph. There's two ways that you can get this answer. One way would be to just go to the table and find 25 in your x column. The other thing that you can do is go to a calculator page, and since you have this equation entered in F1 on the calculator page, you can do F1 of 25. If you type it in just like that, the calculator is going to spit out the answer, 45 meters. Finally, angular and linear velocity. We have a child spinning a rock at the end of a 2-foot rope at the rate of 121 revolutions per minute. Find the linear speed in feet per minute when the rock is released. Now remember, on these angular and linear velocity questions, what we want to do is we always want to start with the rate that is given to us. And in this case, I've got 120 revolutions per minute. And I want to convert this to feet per minute. I know that if we're spinning the rock at the end of a 2-foot rope, then I've got to circle that's being created by the rock with a radius of 2. And I know that 1 revolution of the rock is going to be equal to the circumference of that circle that's formed, which is 2 pi r, or in this case 2 pi times 2 feet. My revolutions cancel out, and I have feet on top and minutes on bottom. And so this would be equal to 480 pi feet per minute, or if you prefer a decimal answer, 1,507.92 feet per minute.